Okay, for those of you who don't know me, my name's Clive Butler, and I've been in the design and manufacture of Yankee Dryers for 33 years now. So, moving on, the evolution of the Yankee shell. Well, when I first started 33 years ago, there was only one type of shell. It was cast iron. It's been used for over 100 years. It has no weldings allowed. It's bolted to the heads, and it has many disadvantages that I will not be going into today. About 20 years ago, the welded shell, steel shell, came into being. The heads can be bolted or welded, and it has a lot of advantages over cast iron. 4 years ago, in 2017, we made our first forged shell. Now this is the picture there, forged in one piece out of a single ingot. There is no welds in it. So there's no seams. It has all the advantages of the steel shell over the cast, but it also has a lot of advantages over the welded, and I'll be going into that today. Okay, so why don't I like welds? Well, first of all welds have flaws, and we must manage them. The weld has different thermal and mechanical properties. Now here we're talking, if you grind at a certain pressure and you change the pressure, you may get different deflections, run-out problems. You also might get wet streaks or dry streaks where the change in thermal conductivity happens. There are high stresses and fatigue stresses in the welds. Now this is where I don't like them the most. In the welds and the heat affected zones, there are a lot of high stresses, thermals and fatigues. It's a safety concern, and therefore we must inspect them every so often. Okay, currently there are no official guidelines on how often you should inspect these welds. So what we do, we take the manufacturer's recommendations and do that. Okay, for a typical example of a manufacturer's recommendations on welds in the shell in the fatigue zones, you should UT it after 2 years and then every 5 years. Now this UT is quite expensive, it's very sophisticated, it's a very good method. They use a Toft or a phased array method. And also they're asking, you should annually visually inspect the welds. Now this means you have to go inside every year because you can't see the welds on the outside. There's a spray coating. This is a large cost in downtime. So you're cooling it every year and going in. And also the specialised inspectors are a very high cost. So that drove us to the ideal forge shell, where we make it in one piece, there are no welds, and we bolt it to the head. Okay, so what about bolts? Well, I quite like bolts. I'm with Enzo Ferrari there. I like them, but they do have their drawbacks. First of all, they can cause a runnability issue. Two things here. One, because of the bolts stick out, they can cause windage. The other one is because they are make a stiff joint at the end, there is a more dip in the shell when they have the sheet on. And I'll explain a little bit more of that at the end. Frame clearance, a personal problem of mine. The bolts stick out the side, so we have less room to fit in to a rebuilds mainly, to fit in between the frames when we quite often want to widen the sheet. Capital cost, always an important point. They are an expensive item. They require a lot of machining. They've got a high, tight tolerance on them on both tensile strength and hardness. We do a lot of inspecting on them. We have to machine all the threads, and we have to have a thicker flange on the shell. So that means much more machining on the shell and a lot more metal to start with. Running cost. TAPI recommends we UT them every 5 years, so it's another cost. So, it has driven us to seek out a new solution, and that is the EVO-Lock. So what our mission was to lock the heads to the shell without any structural welds or fasteners. Okay, so the result was we would mechanically hold the shell. Basically, we're going to hold the shell, hold the head with the shell. Well, it sounds simple, but it's impossible. You can't get the head in the shell. Well, it is possible, and this is how we do it. We take our forged shell with no seams and machine in all the grooves, and then we put some belts round, heating belts. We insulate it as well, and we carefully control the temperature. We heat it up, and of course it expands, and therefore 6 millimeters we get 8 millimeters. Then we put in our head, and we cool it down, and it's locked together. Turn it round, we put in our stay, we bolt that up, we heat up the shell again, and we put the second head in, cool it down, and bolt up the stay. And there, hey presto, we've got a fully machined and assembled Yankee with no structural welds in the shell or bolts in the shell. Okay, just to recap on that, we heat up the shell, we lock in the head, and the other thing we do is we add a small braze on the inside here to seal it. Now this is not a structural weld. It does not need to be examined or periodically inspected. It is purely there to seal. There is no stress on it. So what happens? When we pressurize, the shell comes out, and we have this pocket we've machined out to weaken the head in that area. And what happens is, it acts as a fulcrum. So there's no relative movement between the head and the shell in these places. It is gripped. So what we have is, we grip that there, and then when we pressurize, it goes like that, and then when we add the sheet, it comes back down. So the sheet on goes back the other way, and there's still no relative movement. Let's look at the inspections. Welded recommended UT every 2 years, sorry, every 5 years, but after 2 years. Internal inspection of the welds every year, and then we have to internally inspect all our straws and pipework every 2 years. That's what's recommended by most manufacturers. We also have to UT the head to journal bolts and the head to stay bolts every 5 years as per the TAPI recommendation. So what about the forged and bolted? Well, there's no welds, so we don't UT the welds after 2 years and every 5, and we don't visually inspect them every year. So that's 2 totally out. We have to go in and inspect our straws, like every Yankee. And we have to UT the bolts every 5 years. So what about our new Evo lock? Okay. Well, basically it's the same as a forged and bolted. We have to go in and inspect our straws, and we have to go and UT our head to journal bolts and head to stay bolts. But we have no head to shell bolts, so it's slightly less time. Looking at on a 12-year cycle here. Let me get this laser going. On the odd years, the forged and the Evo lock do not require an internal inspection. This is a big change. We don't have to go in every year. But on the welded, we have to go and do our visual every year on the odd number years. So let's look at the even numbers. Year 2, on the welded one, we have to do our UT. So we have to get our expensive people in and do the UT test, and it takes quite a while. It's also an internal inspection year, so we go in it anyway. Year 4, we don't do a UT, but we still have to visually inspect the weld and internal inspection again. Year 5 is a TAPI recommendation, so we do the bolts. But on the bolts, they're all on the outside, so we don't have to cool the Yankee and go in. So that's a big cost that's not apparent on the forged and the Evo lock. But on the welded, we have to go in anyway to visually inspect the welds. Moving on, year 8 is the same as year 4. Year 10 is a UT year again. It's 5 years after UT the bolts. And then 11, there's nothing apart from the weld. And 12, we're back to 5 years after year 7, where we UT all the welds with our expensive people. Okay, so how does that count up in time? Right. For a typical Yankee dryer, an internal inspection takes about 6 hours. And we do that 6 times over a 12-year period, so that's 36 hours lost. But we do that on every Yankee, so that's the same, whatever Yankee you've got. The weld inspections don't actually take a lot of time. I've estimated about 4 hours. But we do that 9 times in 12 years, so that's another 36 hours. The UT of the welds does take quite a lot of hours, 48 hours, and we do that 3 times. But we, of course, on the forged and the Evo lock, we don't do that at all. So that's 144 hours extra on the welded over 12 years. UT bolt inspections, they don't take a lot of time, and we do that twice in 12 years, so 4 hours. The forged and bolted, a bit longer because there's more bolts. And the same with the Evo lock, not as many bolts. Okay, so here we come to the big one. Time for cooling the Yankee and warming it up. It takes about 18 hours to cool to get inside and then warm up again. That's a lot of lost time. And we do that 12 times in 12 years on the welded, every year. On the forged and the Evo lock, we only go in it 6 times. The even-numbered years when we're going to inspect our straws. So when we total it all up, the welded 436 hours over a 12-year period of lost time. But the forged and bolted only 156. And the Evo lock, even less again, 148. So, concluding, the welded steel shells have a lot of advantages over cast iron I've not gone into. The forged and bolted have all the advantages over cast iron the steel does, but it has these additional ones. Safety, very important. There's no flaws in the welds because it has no welds. It's forged, one piece, heat treated. It's the same metal all the way through. So it's uniform as well. There's no material property changes. The running costs, we've just seen the table. It's quite a lot of downtime for inspecting welds. And for the Evo lock, we have all the advantages of the forged, but some extra ones. First of all, the running cost, there's less bolt inspections, small but important. The capital costs. This is very important if you're buying a Yankee Dryer. We've driven the costs down, it will be passed on to our customers. Frame clearance, my favourite one. I can now get Yankees for a wider sheet in an old frame. And the runnability. The windage issue, it's not a big issue normally. Bolts stick out, it's easily solved. But the other issue is there's less deformation on the edges. So because of this fulcrum point, because we've got that grip there and it is moving this way, there is a less of a dip just inside the sheet where we have doctor problems. And I know most of you here must have heard of this. We have doctor problems near the edge of the sheet because when this stiff joint here moves down, there's a deflection just inside the sheet. And if we don't machine that out with the crown or we change pressures, it's a problem. We don't have that with the Evo lock. Okay, that's all I've got to say. Questions, I'll be available in booth number 1, just as you come in. Or if you've got time now, I don't know.
If there are any. No, but okay, yeah. I think that everybody will come to your booth.
Yes.
Maybe for the chocolate balls.
Chocolate balls, yes.